Hi guys. Just in case you need a little help doing page 6, I'm going to kind of talk you through it. So the first thing I would personally do is type the equation into my graphing calculator. So you want to type x squared subtract 2x plus 2. One of the things you have to be careful of is the subtraction sign and the negative sign read differently. Okay, then when I hit the word graph, I get this picture. Now you'll notice my window's a little bit different than what's on the paper. So if you want that standard window, that's always zoom 6. That gives you that neg 10 to 10, neg 10 to 10 window. So this is actually what it would look like on your paper. To get the points, you just hit second graph, which is table. And what I like to do is center my vertex or my turning point. I do that by making sure that the top and the bottom y values are the same, and that's the symmetry. Now you can do that whenever your vertex has an x coefficient that is an integer, because the table's preset for integers. If you have to change that, you would just go to second table set. Let me try to make the calculator part a little bit bigger for you. Okay, yeah, you would just go to second table set, and that allows you to change your start and your delta table. So, I would still start at an integer, but let's say that my vertex was 2.25. Okay, so what I would do is I would go up by 0.25 so that when I go back to my table, I can find 2.25 easily. Okay, and you would just have to scroll a little longer because now you have to go 4 spaces for every one hole. Okay, so basically this is what the graph would look like. And I'm telling you, copy 5 points. I would definitely copy the zeros if there are any. And in this case, it looks like there's not. The y-intercept, and then you just want to be symmetrical. So that's why I'm saying 5 points. If you're not going to do 5, do 7. But 3 is just not enough to give you the beauty of the parabola. All right, so that would be question 3. And now for question 5. Oh, cool. It's got a negative in front. So the negative in front tells me that this is going to be what I would consider upside down. Normally they're right side up. Oops, right side up, upside down. Okay. So negative x squared plus 4x's subtract 3. Okay, and now here's the graph. So that fits nicely in my neg 10, 10 window, so I don't have to really change that. If you want, you can notice the turning point. It looks to be 2, 1. So I would go second table, and I'm going to change the table set back to integers. So I'm going to start at 0. I'm going to go by ones, and second table. So yeah, it is 2, 1. And this is how I center my vertex. See how I have the negative 24, the negative 24. Okay, so those are all great points. Now for this particular one, I wouldn't go lower than the negative 8 because it wouldn't fit on the grid that's provided. Okay, so now looking at the picture. Axis of symmetry. That's the imaginary line that divides the parabola. So if I go straight down here, that would be x equals 2. The vertex or the turning point is 2, positive 1, sorry. The end behavior, that's like, hey, what's going on with the arrows? Well, they're both pointing down, so that's decreasing, okay? The y-intercept, it crosses the y-axis right here at negative 3. The x-intercepts, there's 1 at 1 and 1 at 3. And then average rate of change. So the average rate of change is you have to find the coordinates of those 2 points. So -4 has a partner of -35. And then -2 has a partner of -15. And then you're just doing slope. So to do slope, it's, y2 minus y1 over x2 minus x1. So I'm just going to put that into my calculator. So I have y2 being -15 minus -35 over -2 minus -4. And then you hit enter, and that gives me an average rate of change of 10. So what that's saying is that if I connected those 2 points and made a line, that line would have a slope of 10. I hope that helps. Have a great day. Bye.